A compound interest problem. She owes a total balance of B dollars after M months. Assuming she makes no payments on her account, the table illustrates the balance she owes after M months. Over which interval of time is her average rate of change for the balance on her credit card account the greatest? So it's not at all an exponential problem. It's just average rate of change. So month 10 to month 60, we're just going to find a bunch of slopes. So y2 minus y1 there would be 2591.90 minus 1172, and you're dividing that by x2 minus x1. 60 minus 10 is 50. So that average rate of change is 28.398. From month 19 to month 69, we have y2 minus y1, 2990 minus 1352 gives us my change in y's. From month 19 to month 69, that's another 50 months. 1638 divided by 50, 32.76. Month 36 to 72, so 36 to 72, we want 3135 minus 1770.80. 0.80 minus 1770.80. Divided by 72 minus 36 is 36. So divide by 36, I got 37.92. This is just tedious. 60 to 73. So 3186 minus 2591.90 divided by, that's a 13-month difference. So divided by 13, 45.7. So which one is the greatest? 4. So that wasn't terribly difficult. Average rate of change, slope, algebra 1. Okay? Number 22. Which graph represents a cosine function with no horizontal shift? Stop there and we can eliminate which ones? 2 and 3. These are sine curves. They're starting on the midline. That's a positive sine curve. This is a negative sine curve. So those are both out. An amplitude of 2. Which one, if any, does that help us eliminate? They both have an amplitude of 2, yes? So here's your midline at 0, 2 above, 2 below. Midline at 0, 2 above, 2 below. So that doesn't help. Period of 2 pi over 3. Well, look at the length of this cycle. Is that 2 pi over 3? Yes or no? No. 2 pi over 3 is way the heck over here. So if you do this, is that 2 pi over 3? Well, 2 pi over 3 is 2/3 pi. Is that about 2/3 of the way to this pi? Yes, definitely more so than 1. Mason, can you just wait for Isaiah to get... Mason, or... Micah, can you wait for Isaiah to get back? Sorry, I didn't mean to call you Mason. The alliteration or the... Oops, sorry. Got me. Thank you. 23. According to pricing, Android phones lose 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone in 1.5 years? So all of these are the PERT formula, yes? I would never write this with the PERT formula unless they said continuous, okay? So on the one hand, and it says every 1.5 years. So here's what I would do. write it the way we would write it, which is the starting value 1 plus or minus r to the t over p power. So to get our final value, we would say it's a $300 phone, 1 minus 0.58 every 1.5 years. So we lose 58% every 1.5 years. They want us to estimate what would the value then be in 1.5 years. So when that is 1.5. So we could just type that in, 300 times 1 minus 0.58 in parentheses to what power? What's 1.5 over 1.5 going to be? 1. So 126 is what it will be. Then you're just going to type each of these in and see which one is the closest. So 300 e to the negative 0.87 gives me 125.68. Well, maybe they'll all be fairly close. That's pretty darn close. 300 e to the negative 0.63. That's 159.78, so that's further away right now. 300 e to the negative 0.58, 167.97, that's further away right now. And then 300 e to the negative 0.42, 197. So that's out. I don't love this question. Here's what I think they did, and I think that we would still get the right answer if we did this other method. If it's the PERT method, you guys would just do 300, the final value equals the principal times e to the r, which is negative 0.58, times t is 1.5. Do you follow that? And if you do negative 0.58 times 1.5, you'd get that negative 0.87 exponent. So they're not exactly going to give you the same number, either formula, but they're going to be in the, really close. So either way would have been fine. Knowing to use just the PERT formula with this rate and this t for time and multiplying them. Okay? 24, last one here. A cardboard box manufacturing company is building boxes with lengths represented by x plus 1, width 5 minus x, and height by x minus 1. The volume is modeled. Perfect. And that's great because obviously if we have a factor at x plus 1, we have a root at negative 1. You see that? If the factor is at 5 minus x, you've got a root at 5, and x minus 1 as a factor puts a root at 1. Over which interval is the volume of the box changing at the fastest rate? This is average rate of change again. So you could actually, you wouldn't want to do all the formulas if you're looking at a picture, but from 1 to 2, there's our average rate of change. From 1 to 3.5, there's our average rate of change. Which one is greater between just the first two? 1 to 2 or 1 to 3.5? Which one has the greatest, the fastest average rate? 1 to 2, the steeper slope, correct. From 1 to 5, that's definitely not it because that has no rate of change. And 0 to 3.5, still that first one is the steepest. So the fastest average rate, if you don't want to do all the calculations, is just going to be the steeper slope. Okie doke. Okay, your time's winding down for the retake on the flashcard. So today after school or tomorrow after school? My meeting got canceled, so if you want to, you can now. I initially did say that, but you can now. You're doing January 2017, the first assignment.